Here are some videos to help you with 1 through 6 in case you had questions on any of these. So, state the domain of the functions below. Write your answer in inequality or set notation. So, inequality set notation is the same thing. That's going to be the one that looks like this. Okay? Let's find the domain. So in order to write the domain about something that has a restricted domain, you would take whatever is under the square root symbol and you would set up an inequality. You need to find all the x's that make it so that way the piece under the square root is greater than or equal to 0. You would move the 7 over and get x is greater than or equal to 7. Let's envision our solutions on a number line so that way this set notation becomes very easy to write. X is greater than or equal to 7. And our answer would look like that. Question 2, I take whatever is under the square root symbol, I isolate it, and I figure out the inequality that would make it so that way the piece under the radical is greater than or equal to 0. So I am going to solve, well actually there's 2 ways you could do this. So if you wanted to do it this way, you would get negative x is greater than or equal to negative 6. If you always like keeping the x on the left, when you divide both sides by a negative 1, the inequality symbol would flip. Of course, if you did it the other way, where you ended up with a 6 is greater than or equal to positive x, you would have to flip it in order to write it on a number line anyway. So it would end up looking like this. Okay. So we have x is less than or equal to 6. 6 less than or equal to, shade in, less than or equal to. X is an element of all reals such that x is less than or equal to 6. Okay, these are my answers so far. Let's look at 3. So following the same algorithm, right, if we see a square root and we're asked about the domain, we take the piece under the square root and we set up the inequality that would make that true. We want to make the piece under the radical greater than or equal to 0. Oh, now it's just a quadratic inequality, and we know how to solve stuff like that. I would take the factored form, turn those into the solutions. That's a 5. And then right at those solutions, we have a 0. And you can envision that this is a upward facing parabola with roots that look like this. So we have positive, negative, positive for our number line. You could also graph it, or you could do test values to help you envision what's happening across that number line. So if you substituted in with test values, you would put a negative 6 in there, and you would get a negative times a negative, which would give you a positive. If you tested in a 0, you would get a negative times a positive, which gives you a negative. If you plugged in a 3, you would get a positive times a positive, which gives you a positive. We want where the piece under the radical is greater than or equal to 0, so we would shade down from here and up from here. Okay. Okay. And then now we have the same idea. We're going to take that piece under the radical, set up an inequality so that way it's greater than or equal to 0. This guy looks like he needs to be factored. This would be plus 6 minus 2. Those become my values on the number line. Oops, negative 6 comes first. Okay. These are zeros. And then this is an upward facing parabola, so we would have positive, negative, positive. We want where this thing is greater than or equal to 0, so I would get negative 6, shade down, get 2, shade up. And those would be my solutions for there. Okay, and then now, this guy's a little trickier, but same algorithm, same every time. You see a square root symbol, you take the part under the radical, and you set up an inequality to find all the values where that guy is greater than or equal to 0. So now I would split and solve. This guy would become negative x equals 0, which just means x equals 0. This guy would become x equals negative 7. And those become my pieces on the number line. Okay. And then this guy's a little harder to envision what he would be doing, right? So, I mean, he has a negative out front, so he would be facing downward, right? But if that's not obvious or available to you, you could just test the values along the number line, right? So I'm going to do negative 8. I'm going to do negative 1. I'm going to do 2. If I plug a negative 8 into the factored form, I get a positive 8 times a negative number. That's going to give me a negative down here. If I take a negative 1, that's going to give me a positive 1 times a positive number. That's going to give me a positive here. I plug a 2 in, I get a negative times a positive. This will give me a negative over here. Okay, so I want where this guy is greater than or equal to 0. So I would have a sandwich between negative 7 and 0. Okay, and then for here, I would take the piece under the radical and set up my inequality. So I need all of my inequalities to, oops, sorry, I need them to be greater than, stop it, greater than or equal to 0. So what would make this thing 0? Well, if I take the numerator and kind of isolate that guy, right? T is greater than or equal to 0. That's going to become one of the critical points on my value, on my number line, right? And then the other one, I'm going to have to find where this thing has an asymptote, a vertical asymptote, because there's a denominator. I'm going to have to restrict the domain to get rid of that value. So I have 1 plus t